Mario once again with MIA Flight, and as some of you have seen my recent videos on rubber-powered helicopters, I decided to bring one of my old 92 version MIA 500 RB, which is based on the Hughes 500, back into view here, and I've been doing some videos with that. But I also decided to bring some of the more or less complex helicopters that I also did back in those years, like the Feather, MIA Feather, MIA 123. I also used to sell those in kit form, more aimed at kids, young kids, that just wanted to build something real quick and have a go at it. And so I did some more simplistic ones. I decided to also bring those back into my more up-to-date CAD program, and have been playing around with some designs here. And these are what you're. This is actually the physical versions of those designs that you're seeing here. And just a couple. I have been working on several of these types. And where is my boy? I have another one here that I did also with pulleys, more like the 500 is done. But I did one of these guys right here, these open frame designs, the more simplistic ones. I'm calling these the MIA Feather because they use a feather, to counteract the torque of the main rotor. And I have been trying to establish a balance here. It's almost like starting from scratch as far as the aerodynamics here is concerned. Because back in the day, I used to use a lot of balsa wood. Everything was balsa wood. Balsa, none of this 3D printed stuff, carbon stuff, was available at the time that I was experimenting. Back in the early 90s, late mid to late 80s, when I embarked on experimenting with rubber powered helicopters. That's how I got a good understanding of the workings of helicopters, by doing this kind of work. From here I went on to free flight, electric free flight, and then eventually I developed the radio control helicopters. So a lot of that is work that was based on the more simplistic, if you will, versions, just a rubber powered helicopter. And I've done all kinds of mechanical setups, including the flybar with bells, the bell stabilizer, the bell and Hiller stabilizer, all those things that have been employed on real helicopters. Um, I employ on these rubber powered ones. And so what you see here is just a bunch of parts that I want to focus in on some of the stuff that I have been doing. I have some gears there because I have done some gear setups here. Pulleys, as much as I have wanting to do one of these guys with a belt system with a with the pulleys, main to tail pulley. Here's the other little pulley right there. One of the pulleys there. Here's another type of pulley. Anytime you start adding all these little parts that I show here, and the reason why I removed this one, and this is almost like a third version of this one, because I started with this design here, and then from here I decided I need to kill some of this weight here, and so I went to this particular design here, and I show that in some other video. I'm showing the mechanics of this, and this really spins really nice and true on the shaft. So I started killing some of this weight and even some of these parts that I designed, for the various types of frames. They just add even the base that I designed here for this model right here. You can see how I slotted this just to remove some of this weight in this kind of a crappy part. I think, yeah, this is a fail part, but I decided to keep it because it's the one that shows the slotted version here. And this is what I show here in my models here. There's the slotted version right there. There's the original one, although this is also has a it's concave on the inside, to remove a lot of this plastic weight that's unnecessary and just keep it reinforced where it needs to be reinforced. So I've been cutting down a lot of that weight, and even so that this particular model flies really good. And I showed that in some recent videos. I was doing some flight tests with this model recently on some early videos. I'm still trying to get as much not so much height, because height you can get just by adding a bunch of strands here, and it becomes really torquey. where it has enough power to spin the rotor to lift it high, but when it reaches a certain point, the model stops rotating because you have so much torque and not enough speed that the model just drops to the ground. Anybody that has done experimentation with rubber powered understands that. This is more for the people that don't have any clue, to these things. And so that's my direction, because I don't think I need to explain this to anybody that has done that understands aerodynamics, understands power to weight ratios, understands rubber powered strength, number of strengths, all those things. We're talking true engineering here in the models that don't seem like they employ a lot of engineering. But in the way I like to approach these things, I use all those things. I take into consideration all those things, and anybody that's serious about building models for with efficiency, for longevity, for structural integrity, understands these things. Those are probably the guys that you're not going to see commenting on my videos, because they already know this stuff, and maybe this is already known to them. I've had engineers from NASA sometimes. In the old days, I used to get email, not emails, but regular mail. Correspondence via written letters from people that used to work for NASA. They used to write to me when I embarked on doing these things, and they were giving me their 2 cents on either pro or con. Sometimes I would get people that did not want me to embark on this for some reason, wanted to stifle my operation. I've been doing this for such a long time. If that says anything. And many of them were people, just nice people. They were giving me kudos on a lot of these things, and saying that they wish that they would have done this earlier, to understand a lot of the aerodynamics that are involved, in these types of aircrafts, from models to the real thing. If you understand, the basics, the concepts of flight, of propulsion, of materials, you're probably going to understand that in any area that you're going to, whether it's a model or the full scale. I'm kind of one of those rare individuals, I think, that has had the luxury of starting from the bottom up in the way that I think true engineers should be taught. Most of the time, you have engineers, and including myself, not with respect to aerodynamics, but with respect to other areas of engineering. I went to school to learn some things, and unless you're the type of person that are hands-on, or you go to a school that allows you the hands-on as well as the theory end of instructions or education, it's very hard for somebody that only gets theory to understand some of these things that require somebody more hands-on to really understand and how to approach and how to resolve problems. And more than anything, engineering is about solving problems. And that's also the fun part that has been, for at least for me, in getting involved with a lot of these things that I show. Even though I'm showing really simple stuff right here, but just go to my channel and see all the stuff that I've done in all the years that I've been posting on YouTube, and you can see all the stuff. I don't think there's any other company or individual that has shown as much as I have shown. And I know there are other people that have tried to do the same, and many of them have failed because either their heart is not there. You really have to. There are people that love books. Let me put it this way. People that love reading books, and you can see by their libraries that they build. And there are people that really love reading, and there are people that only have books to showcase that they appear as the intellectuals, and they're not. They're just con artists, fake. So you either love this thing. I truly love these things, and I show that through all the work that I've done through many years, through stuff at my website, through stuff at my YouTube channel, through stuff at Facebook. There's so much stuff. If you just type MIA Microflight online, you're going to stumble on a lot of stuff. So that shows true heart for the stuff that you do. And when you have true heart for the stuff you do, you are going to understand that by nature of having a true interest in that, as opposed to somebody that just wants to be a wannabe and wants to showcase that they know how to do these things and they have a true love for that. They don't. uh, so that is my point with that, and my comparison to somebody that honestly reads books. That person is going to come out as knowledgeable in all the subjects that they profess. Interesting that a past leader of our country was asked, can you name a passage in the Bible, since you say that you've read the Bible and you are a person of faith. Can you name one passage in the Bible? And he was like, no, I'd rather not say that. No, there's something personal. That's total, pardon my French, bullshit. Because when a person truly understands that and is true to the nature of such, that person has no issues pointing examples. And that's where I'm coming from. I didn't want to bring that up, but that's a good example of character in people. Getting back to this thing right here, what I'm showing here is once again they're very simple designs, and and what I have been trying to do is basically cut as much weight with these 3D printed parts. Now you can see here I use carbon rods, like I was saying in my early designs. I use a lot of balsa wood, which is in effect not a bad option, even to this day, because balsa wood. If you select the balsa wood as I used to select the balsa wood, I still have a lot of that balsa wood sitting in boxes, from over 30 years that I've had, that I used to do this kind of work, originally. That still works. It's still good. That's still lighter even than some of these parts that I'm showing here. But because we live in modern times, it just justifies to do these things in modern materials, and that's what I'm showing here. This is nothing new in terms of the shapes that I designed here. A lot of these shapes I had them back in the day, but I have brought a lot of these things more into more PLA 3D printed materials. Now there is some 3D printed filament that is lighter than PLA. I think they called it light PLA, even maybe, which could be used here, for some of this stuff right here. I don't, I didn't go that far. I don't need that material right away, and so my approach has been to just cut as much meat out of these 3D printed parts to keep the model extremely lightweight. I even went with this model. This I did last night. And you can see the carbon rods here, aside from the verticals, which are 2mm carbon rods. I went with the 1.5 on the landing gear, and I even went with 1.5 on the tail end here that you see here. Oh boy. Let me put this back. Carbon rods on the tail, and although it's a little bit flimsy in terms of torsional stability, I think it'll be fine, once I put the fin there. And this is something that I'm designing also on the computer. This is going to be just a paper fin and a paper type of foamy pilot that's going to sit. The same pilots that I've used on my other models, such as that one, and I've shown some other stuff before. And so I decided to just bring my pilot bag, my famous pilot that I've also used on radio control helicopters, in more of a three-dimensional form. So that pilot is going to sit right there, and it's just going to add a little more pizzazz, to this helicopter, which would otherwise just be, a skeletal framework here. Now I've also gone with, as you can see, the evolution of these kits right here. And like I said, this is stuff that I've done many years ago, but with these new materials you almost have to start from scratch and just kind of go back and try it. And this is more of a trial and error type thing, until you arrive at the right balance. And so my goal is to establish not only height but also flight time. I want this model to fly as high as I can get it to fly, but also maintain the same momentum in speed rotor coming down, so it doesn't come down like a brick, like most of these helicopters, do-it-yourself helicopters. People that don't know what they're doing, they show. And so that is the thing. You can also see that my bands right here are I'm not going to say how many loops I have there just yet because I'm still experimenting with them, but they are wound in a particular way, to establish not only the torque but also the power with minimal loops and minimal width and minimal weight. Overall, is weight, because anytime you put too many rubber bands or too many these are not rubber bands, this is contest rubber that I'm using here for designed for free flight models, and this stuff that I've had for years. So it's not as good as the something brand new that was just manufactured. So it's been sitting in a bag, and I got a lot of that stuff. So I've been using that. But the problem is that it's not as it's all rubber. Let me just say that. So. And I can probably get a lot a lot more power and a lot more turns, from something that's more recent. So I'm in the process of ordering more recent rubber for these models here. But this is what I have, and this is what I've been using. Oh, I almost dropped my phone here. So, pardon that. So, I have been, so I wanted to show the evolution here from that to that to that. I've been increasing also the size of the height of the height of the motor. Without making it too gaudy and making it too distracting. And like I said, with my Pilot, I think my Pilot's going to balance that out. That's the reason why I'm using my Pilot here. Okay, so this is in the process of being built. It is a much lighter lighter structure than any of these other ones, so I should be able to get more flight times than this particular one, which I've been getting some really, really good flights. I was testing this at night when it's calm, in the middle of my cul-de-sac here, where I live in the center of it, and just letting it rip, and it's been working really great at that particular size with this weight here. I use 2mm carbon rods throughout this whole thing, and this right here is just a nylon piece of tubing that I use just for durability. I'm not using balsa wood in any of these things because the balsa wood tends to crack if you hit too hard and tends to break, and that's the other reason why I decided to bring these into more modern materials such as carbon and PLA here. So, and nylon. This is the same nylon that I use consistently on some other products that I produce here at MIA Microflight. So it's just justified for me to use that. What was I going to say? Yeah. So this is where I'm at right now, and this is I should be able to do a video of this soon. And you can see my fins are nothing too elaborate. That's another fin, really, really very crude here, but it doesn't need to be spiffy at this level right now because I'm still experimenting with this, and I just want to get the right area. More than anything, this is just how much area do I need, at what length do I need to establish a counterbalance there, a good counterbalance that's not going to allow the helicopter to yaw too much, and provide that balance so that the helicopter is able to go up and come down in a circular fashion. I want this to come down in a circular fashion, nice and easy, to a landing with the rotor spinning. That is my target here. Once again, MIA Microflight, and this is the kind of stuff that I do and the way I do things. Stay tuned for more.